Live from the North Carolina Museum of Natural Sciences in beautiful downtown Raleigh, it's the Science Cafe.
Welcome, everybody. Welcome to the North Carolina Museum of Natural Sciences and the Science Cafe. Tonight we have a very engaging conversation to have. It's about how to get started in 3D printing. Does anyone here not know what 3D printing is? So you're an apt crowd. And everybody here wants to learn how to get into 3D printing? I've heard strange things about 3D printing, that on the International Space Station, NASA wants to put a 3D printer on there because they figured maybe the astronauts could learn how to print pizzas. You don't get pizzas out of tubes, you know. So that was one of their ideas. I'm sure they have so many other ideas. It's an intriguing field. I think we've all heard a lot about it. Just as a little bit of background, I started my career 40 years ago as a printer's devil, and that is a printer's assistant. And I was working in a printing museum, and of course we're all familiar with printing. And I learned from working in that museum how revolutionary printing was, the printing press, how it came. It brought upon us the Protestant Reformation. And then in short order, in a couple of hundred years, we had the American Revolution, which was really not possible without the advent of the printing press, believe it or not. So today we have this nascent new 3D printing field, and we're sort of getting to know it a little bit. We see keychains being printed by, people using them that way. We hear rumors about people starting manufacturing, where we don't have to have a factory in a big scale up to put something into the market. So Matthew Faerber here today is with our visualization lab on the 3rd floor, and I'm sure you've all been there before to see his makeup. So we're going to bring Matthew out. He's been working in 3D printing and 3D modeling, so he'll sort of show you all the ins and outs of this new field. So Matthew, why don't you come up? Matthew, just want to ask you, it seems to me that if you're working in this field, you must have been an engineering background. Is that right, that you were an engineer when you went to school?
That is incorrect.
Oh.
I have a visualization lab, but I do not have a degree in engineering or computer programming. My degree is in environmental science. As I like to tell everyone, especially children that come into my lab, technology is one of those rare subjects where you can learn how to do it on your own. You can take classes here and there, but you can also learn from it using the internet and maybe wind up at a museum someday.
Sign me up. Take it away, Matt.
All right. Well, thank you for coming, everyone. Again, my name is Matthew Faerber. I'm the coordinator of the Visual World Investigate Lab up on the 3rd floor. It's open nearly every day. It's free for everyone. We do classes in there, and we create exhibits on topics ranging from scientific visualizations, but also electronics and robotics and GIS. So I welcome you all. If you haven't been there before, to please come up. We'll show you everything. There are a few images of the laboratory. It's a little bit funky, but it's a lot of fun. So tonight I'm going to talk about 3D printing. Now, I believe that in most cases, talks about 3D printing involve what's really cool about 3D printing, what's new about it, and all the different things that you can do with it. Well, I'm not going to focus so much on that as I'm going to focus on how you can get started on it, the cheapest, most inexpensive way, and try to demystify the whole process for you at the same time. So what is 3D printing? You can see on my slide here some time-lapse imagery of my printer here in action. 3D printing, also known as additive manufacturing, is a process of creating an object from scratch. You start, in most cases, with a raw material like this. This is a plastic, a corn-based plastic. And then you can turn it into a model of your choosing, any kind of shape that you would like. So a lot of people have trouble understanding exactly what that looks like or how that works. It's really, if you imagine a hot glue gun has glue sticks and a nozzle that heats up to be very, very hot. It melts the glue and extrudes it. That's basically what this does with plastic. It has a spool of plastic in the back. and it feeds that spool through a nozzle that gets incredibly hot. And then the nozzle itself is able to move left and right, forwards and backwards, and then the platform below can move up and down. So you have X, Y, and Z space there that it can move around in. So it'll slowly create the model from the bottom up. There are other types, but that is the most common, certainly for beginners. So what can you make with 3D printing? Well, virtually any shape. And no matter what size your printer is, you can make your parts and pieces and then put them together later. So just a few examples would be toys and prosthetics. Right? I've done that before, where I've made a prosthetic hand. That's something that someone can actually use. Robots, all sorts of fun things. It can really be anything. It's limited only by your imagination. So what are your options? I'm only going to give one option for one specific printer because there are many types of printers. So I went out to search for the cheapest and probably easiest to use for beginners at this very moment. So the cheapest one I was able to find that has some good ratings is about $237. It's called the Mini Fabricator 3D printer. It can only make objects just a couple inches large. It's not very big, but it's a great way to get started. Now, if you can get something a bit bigger, on my slide here as well, and I have a handout here that you all can take or take a picture of with links. There's a 3D printing guide online, a very good one for this that's recent, from this year, that lists lots of different 3D printers on the market right now that are recommended and breaks them down by price and by positives and negatives. So you can find out whether detail is more important to you or availability of the filament is more important to you. You can check all that out on the website. But at the very least, there's a good little cheap one to get started with. The one that I have right here, this is a MakerBot Replicator 2. MakerBot was probably, it wasn't the first 3D printer, but it was one of the first, probably widely distributed and most popular among the maker community. So you'll find quite a bit of information about these guys online. They're good printers. They're good quality. I don't remember what the cheapest printer is off the top of my head, but it's over $1,000. So filaments, so the stuff that you actually make your shapes out of. There are lots of options. Of course, there are 3D printers that print in things other than plastic. There are printers that print in metal as well. However, those are very, very expensive. The ones that use plastic, the most common types, have plastic that come in many different varieties. You can get plastic in any color that you could want. You can get flexible plastic. You can get plastic that glows in the dark. You can get plastic that contains wood fiber. So it actually kind of looks like and even smells like a wood product when you're done, and you can sand it and everything. There's even conductive filament that's starting to come out now. So you can actually print out your own circuit board and then print a circuit on top of that. It's plastic that's imbued with graphene. It isn't perfect, but you can make some simple circuits with it. So that's extremely, extremely powerful. And as you can see on the slide, filament is pretty cheap, I think. A reel of this is anywhere between $20 or $40 for a kilogram. And that lasts quite a while depending upon what you're making. And that's something you have complete control over, which I'll talk about later. All right, so where do 3D models come from? So you have to, the machine can't read your mind. You have to send it a file. You have to connect it up to a computer and send it a file, or put the file on a little memory card in the case of this computer, and put it into the machine. Well, you have lots of options there. You can either download a model that someone else has already created and has made available for free, and then send it directly to the printer and print it out. One of the most popular and largest websites for that is a website called Thingiverse, where you can download models for free and talk to people that have done it as well and read their recommendations. Another option is to scan an object that you have in your home to make a replica of it. So say you have a broken part or you have just something really cool that you'd like to make a replica of, you have two options there. One is to buy a 3D scanner, but those are very, very expensive, and the cheap ones don't work very well, so I don't even recommend any of them, even though I do have one. The other option is to use photo capture software. So there are lots of programs that you can get that allow you to take pictures of an object from every different angle using any phone you want. It can be your cell phone, or it can be the best camera that you have. You end up taking a picture of an object from every angle, a couple dozen pictures, top and bottom. You send it at the software, and then it can determine what the object is, what it looks like from every angle, and it'll turn that into a 3D model that also includes a photographic overlay of what that object actually looks like. And then you might have to do a little cleanup because maybe it's on a tabletop and you want to remove the tabletop. But then you send that to the printer and it'll print that out. We've done that as well. It works very well. There are different options for that. One of the ones that we like is called 123D Catch, and it's, again, completely free. The last option is to make your model completely from scratch. And that, to me, is the most fun thing, especially if you want to make something that no one has made before. There are programs that allow you to start off with a very simple shape, like a sphere or a cube, and then you push and pull, and you contort that shape into whatever you want. And then you send that to the printer, and all of a sudden you have something that you made virtually by hand. And that's a lot of fun. So I listed 3 of the most popular options here. The first 2, Mesh Mixer and Sculptress, are both completely free options. Sculptress is a really neat one. It starts off with what looks like a round ball of clay, and then there are different tools that you can pick, tools that allow you to poke into the clay, tools that allow you to build up the clay, but it behaves like clay, very organically. So it's a very comfortable program if you've ever worked with clay before. The last option there, Blender, that's my favorite. That's a program that wasn't designed, at first at least, for 3D printing. It was more designed for creating 3D models for things like video games and movies. You can make all those things using that program. But you can also use that program to make 3D models, and you can make them look absolutely however you want. You have infinite control at that program. It's a lot of fun to use, and it's a great skill to acquire. And it's open source, which means that it's completely free as well. And there's a huge community of people behind it who use it, so there are lots of tutorials online. And so what I will lastly like to do, after I maybe take a couple questions, is do a live demonstration, not just of the printing, because printing is kind of slow and not very entertaining to watch. Something about this size takes about 10 minutes. But I want to show you the process from start to finish of how you actually create a model from scratch on your computer and then spit it out here on the printer to try to demystify that whole process. So you can see how easy it can be as long as you spend a little bit of time doing it. So before I do that, does anybody have any basic questions? And then I'll take questions again while I'm doing the model. Yes, sir. Oh.
Can you use files from programs like SolidWorks, if you're familiar with that?
Yes, absolutely. Each printer comes with software that's kind of like the last step, and it'll accept the most common file types like STL and OBJ, which are very, very common. And most any 3D modeling program has the ability to export as that file type. So absolutely, yes. Yes, sir.
I may be hallucinating this, but I thought I saw a 3D printer that it was some kind of bath, like a liquid resin. Oh, so I wasn't hallucinating.
No, you weren't.
Okay, thanks.
Not that time. No, those printers are amazing. Those are called, let's see, what's it called? It's called stereolithography, I believe. So they're magical. So there's a resin bath. Imagine a little dish full of this liquid goo. And what it does is, instead of, it's completely different from this. What it does is the platform that the object builds upon starts at the top of that bath. And then underneath that bath is a laser that shines for an instant light that is the shape of the bottom of that object. Then after it does that for a fraction of a second, the platform raises a little bit, and then the laser shoots another image of what that object looks like about maybe that far up. So it keeps doing that. So if you look it up on YouTube, it's amazing. What you see is this bath with nothing in it, but then as a platform is raising out, this structure is appearing out of what looks like nothing, because the laser is I believe it's hardening that resin in very specific places. So you end up getting the shape out of the bath. That is the other most common type of printer. It's a little bit more of a hassle right now than this additive type, so I don't necessarily recommend it for beginners, but it has lots of advantages. You can do lots more details, especially in like the crooks and crannies and empty spaces of your printer. Because as you may see tonight, and as you can see, I have some examples of on the table here. If you have an object that has overhang, like this is half of a model here. This is what it looks like in the middle of a process. If you have an object with overhang, it creates these temporary supports that you then have to break off afterwards. So this is the bottom half of a bird. And so that right there is its tail, and then you can see those parts you end up having to break off. They call them little supports. So that's a good question. That's a really fun type of printer. You have any other questions at the moment? Yes, sir.
Yeah, like in photography, you could take, the beginning photographer could take negatives or film or whatever to a photo mat and have it done. Do you know of any services that if we took sent the file to, they would print it for us cheaply?
Yes, they do exist. I don't have any to recommend right off the top of my head, but you can find them pretty quickly using Google. I do know that they exist, just for a few dollars a piece. Absolutely. Yes, sir.
Host operating systems, Mac, Windows, Linux?
All of them. Yes, they generally, there are many different manufacturers of 3D printers, but they generally make their programs available for any system, because these are made for maker communities, and we use everything. Yes, sir. Oh, I'm sorry. Yes, sir.
Would you explain how the 3D metal printers work and what metals they use?
And what they use?
Metal.
Metal. Oh, the metal printers. I don't know too much about the metal printers, to be honest. I believe that it's additive like this is. It might start with a powder. Some plastic printers start off with a powder. But I can't tell you much more about that. To put down a powder and use a laser to bond it all together. I think you're correct.
Yeah, I think they use it to fuse them, and I guess they can make real parts out of them. But then one magazine I was reading said they like sometimes use them to make molds to, like if you're going to make a carbon fiber part, they use that to make the female mold to put the carbon fiber part in.
That's correct. I've heard that as well. And I know jewelers are starting to use them as well.
On your slide there, you characterize Blender as advanced, but Mesh Mixer and Sculptress as beginner. How big of a difference is there between the beginner level and the advanced level?
Between these programs, an enormous amount of difference. An enormous amount of difference. For the most part, with Mesh Mixer and Sculptress, it's when you start up, they're designed specifically for 3D printing and for people who haven't done even modeling before. So when you pull it up, there's nice big buttons with images on them, and there aren't too many menus. But Blender is completely different. There are menus upon menus upon menus, because it's made not specifically for 3D printing, but for making true to life 3D models and animations and Pixar type movies with. But as I'm going to use it here shortly, you'll see that you can quickly make really simple shapes with it as well. Yes.
You mentioned earlier that you could put wood fiber in the plastic. Can you also put in some other reinforcing fibers like Kevlar or carbon fiber into it to make it extra strong? And can you also use different kinds of plastic, some that are much stronger than other kinds?
That's a good question, yes. So the filament, you don't have control. You buy the filament as it comes already. So you buy the wood grain filament, it already has a grain in it. That's not something you can really do. There are machines that you can get that'll make filament for you using the scraps that you have. So I suppose you could experiment with that. There are plastics that you can get that are harder than others. Roy was mentioning the printer on the space station. It uses a harder plastic. In fact, you can buy that exact plastic that they use. So yes, there are various different types, and I suppose you could make your own if you bought one of the machines that'll make the filament for you. Most machines that use plastic, like this one here, can take two basic types: PLA, which is a sugar-based, so that's what I like to use, and ABS, which is like bottles, and it's medical grade plastic. That stuff I don't like to use, even though it is stronger, because it's very noxious. With this stuff, it gives off a pleasant, sweet smell that's probably not doing any damage to you. Yes, question?
Can you print with both plastics and metals at the same time, or does it only take one material?
For this particular printer and most printers and all entry-level printers, it's just going to be plastic. I haven't heard of any machines that can do plastic and metal at the same time. I'm sure that they exist. They probably cost many thousands or tens of thousands of dollars. Yes, a couple over here.
I'll get there first.
So you said you use a sugar-based plastic? POA, is that what you said?
PLA, yes.
And so I know several people now that are into this maker movement of the 3D printing, and I was wondering, because I see a lot of waste off of it. What do you think? Is it good for the environment that we can all do this at home, or?
That's a great question. So a couple things to say about that. First of all, I have a couple boxes of scraps. I keep all my scraps in the hopes I get one of those machines one day that'll pulverize it all, and then all of a sudden I'll have lots of free filament. So I'm keeping all that. Second of all, what do I think about the environmental impact of anyone being able to print plastic? It'll end up having a net positive effect, because instead of having your widget being made across the seas somewhere, and then maybe the supply sent over there, and then made over there, and then shipped back over there, and then driven over roads to a bunch of different stores, and then you have to go to the store and get it. You have the plastic, and you make it right there. So all that energy and all that electricity and all the gases that are emitted from that entire supply chain is completely eliminated, or dramatically eliminated compared to the energy that it takes to ship one of these to your door and then use the power from your house to make something that you otherwise would have had to have ordered from scratch. Yes.
Yeah, I was just wondering about how accurate can you be with some of these beginner software? Like if you needed to make something that had a certain size bolt go through it and it needed to be a certain length, like is it pretty accurate? Is it pretty easy to do, or are you really just pushing clay around and hoping that it comes out right?
With the first two, Mesh Mixer and Sculptress, I don't think you could, I don't know that you could build something like a screw, for example. It does replicate, it's very organic, it does replicate the feel and effect of moving clay around. Blender is the opposite. There you can be very, very specific. In fact, there's even a screw feature built into it for making threads and things like that. So it also depends, when you're getting down to fine detail, what's very important is the resolution of your printer. So what that means is different printers and different printer nozzles can print thick beads of plastic or narrow beads of plastic. It all depends upon the size of the hole of the nozzle. So if it's really small, it can print very, very fine detail. Aside from that, you can, in the settings of most, if not all printers, you can adjust the resolution. You can adjust the thickness of the bead that it lays down. The smaller the bead, the greater the detail, but the more plastic you end up using. So I always try to use as little plastic as possible, so if it doesn't matter too much. Now, you can also, after the printing is done, even with this plastic, it sands very well. So you can sand it down. It paints very well as well. Ready? Yeah, so have any more questions? Yes, I think one more question, and then I'm going to do some a live demonstration, and I can answer more questions once I get started. Yes, yes, sir.
Can you 3D print a pen or pencil that works?
A pen or pencil that works? Let's see. Well, you could use the wood grain filament to print the outside of the pencil. For the lead part, maybe that graphene filament will leave a bit of a mark on paper. I'm not sure, but that would be the best thing I could think of. Yes. Now you could buy lead like for one of those pump pencils and put it into something you printed out. That's a good question. Okay. Yes.
I have a question.
Yes.
So it seems to me when you put it in the thing that scans it, it's scanning the outside of this whatever it is you're trying to print.
Correct.
If you have, I've heard that you can print machines, a working machine. You're going to have to take apart the whole thing, all parts of it, and print each part, and then put it all back together, right?
That's right.
And the pencil, you just have the outside of the pencil, so you really couldn't have anything on the lead on the inside. You just have to have a tip of, right? It's all about looking at the object outside.
Yes. You would, if you wanted to make like a motor or something, you would have to print it in pieces and then put it together after it's printed. Now, there is an exception. There's another special type of filament you can get that dissolves away in, I think it's acetone, but I could be wrong. So in that case, you could make something like a hub with ball bearings inside of it. So you have the ball bearings, a filament that doesn't dissolve, and everything around it, something that does dissolve. So then you can print it in one go, and you don't have to put anything together. I saw a hand over here, and then I'll get to it.
Does the infill inside of a object that you're printing matter?
Yes, so that's something I didn't bring up, the infill. So the inside of a 3D model, it can be hollow, it can be 100% filled in, or you can adjust the amount of plastic that goes into the inside. That's called the infill. Most, or at least, or many printers use a honeycomb shape because it's a very strong shape on the inside. And this is something you can adjust. You can adjust how much plastic is on the inside. The more plastic is on the inside, the stronger the model is. So it all depends upon how strong you need your model to be. If you do it at 100%, then if you're printing something large, it's going to use a lot of plastic. So that's something you have to take into consideration when you're making a model, how strong you need it to be, how much plastic you want to use. Okay.
One more.
Yes, one more.
Is there a specific place you need to buy a printer?
Specific place? I believe that there are some stores where you can buy them now, like office supply stores. However, the websites that manufacture the printers, like MakerBot, like that smaller one that I described, let you buy them from their sites. And of course, Amazon has them as well. The website for that small printer I talked about, I remember now, is Hobby King, a very popular website for hobby supplies. Okay, so I'm gonna start this, and if there are other questions, they could just raise their hand and just shout it out. But I'm gonna be looking at the computer now.
So Matthew, what do you think is what would be one of the biggest uses for 3D printing in a household? Matthew.
I think in the household, well, it depends if you have kids or not, probably, first of all. If you have kids, it's probably going to be Legos and toys. If you do or if you don't, another good thing you can use them for is fixing parts that have broken. Maybe you have a broken knob somewhere or something like that. You can you can recreate it and then print it out and then use that. So what I'm looking at here, if you can see on my screen, maybe you can't. Okay, let me hold on just a sec. I'll replicate my displays here. What I'm doing is I have pulled up the 3D modeling program Blender, and I'm going to duplicate. All right, should start coming up now. There we go. Okay. All right, now, let me take this for a second. All right, from the audience, I'm going to take a suggestion for someone that would like to see something 3D printed, maybe from one of our younger audience members. Can anyone think of maybe like an animal, maybe something interesting that they'd like to see printed? I think I saw that hand in the back go up first. A giraffe? A giraffe. I'll do that. That was she had the microphone there. What would you like?
A bird.
A bird. Okay. Let's see if I can do two at once. I think we're pushing it if I do more than two at once. Okay. So I'm going to create a 3D model of a giraffe and a bird. What about giraffe with wings? How about I do that? I'll do a giraffe with wings, and I'll print out two of them. Okay? So I'm going to do this from scratch. Okay. So we still don't. Oh, I know what I did. I changed this, but then I didn't say okay. Should come up on the screen here. Okay, keep changes. All right, okay, now we're good. Okay. All right, so here I am inside of Blender, and I start off with a simple shape. In this case, I'm going to start off with a cube. Now what I need to do is I need to split this cube up, and I need to extrude it into the shape that I want. So this cube that you see on the screen here will start off, this will be its main body. So I'm going to go ahead and let's squish it a little bit. So this is like the top there is the back. Now I'm going to start by making its legs. So I'll make its legs by cutting it up. Let's redo that here. Cut it up. All right, cut it that way. And then I'll cut it this way. Okay, so now I've divided that cube up into many sections here. And I'm going to grab what will be its legs. And they're going to be long legs because, oops, I'm going to extrude them. So there, it's nice long legs. So there's legs and a body. And I'll give it a little tiny tail because I believe giraffes just have small little tails. So I'll just give it a little numb of a tail. Okay. All right. Is it longer than that? All right, tell me when. Is that good? Okay. And then, let's see, I'll have it go down like that. All right, now I'll taper it. Taper it there. Okay, now I'll give it a neck. Oh, who's the painter from PBS? Who's that guy? Bob Ross. That's what I feel like right now. This is what Bob Ross would do if he were with us today.
Nice neck.
Nice neck.
Long.
Yes, nice long neck. Happy neck. Give it a happy neck. There we go. Okay.
That's good.
Nice long neck. Now we'll do its head. Put it up here, and I'll give it its little horns as well. Okay, there's its face, and let's see, give it its horns, maybe there.
Can you make knobs on the top of the horns?
Little knobs on top of the horns? Sure, why not? We'll get it exact. Otherwise, what's the point? Okay, so there's its head, there's little knobs. Okay, so now this is gonna be a bird giraffe. So I will, let's see here. I don't know how good I am at making wings. We'll see how this goes. I have no guarantees. Up like that. And then they might be a little different, but it doesn't exist anyways. There. And then okay. Let's move them back a little bit. back a little bit. There. Okay, that kind of looks like a giraffe with wings, right? Now, this is going to require, no, thank you, yes. This is going to require a fair amount of supports because of all these things that have overhang here. I'll forget that. Now, let's see, that's pretty cubic. I can make it a bit smoother. Do you want it smoother or do you like it cubic like this? Smoother? All right, we'll make it a bit smoother. I can use a special little tool for this. This program comes with lots and lots of tools.
Make the feathers.
Feathers? Okay, sure, yeah. Oh, I have all night. All right, there we go. That's pretty smooth. Okay, so there's a nice giraffe. It has pretty pointy feet here. Let me make its feet a bit less pointy so it's not tiptoeing here. So this 3D model, as you can see, is made of polygons, and you can modify the polygons. You can modify you can move their sides around, but you can also move the corners around. Those are called vertices. That's what I'm doing right now, so it's not standing on its tippy toes. And I think that's good. So now what I'm going to do is I'm going to export this guy. Call him giraffe. I'm not sure how giraffe is spelled, so I'll do that. Export giraffe as the file that it likes. And now I have to bring the giraffe into this program. So every 3D printer comes with a program that's kind of the interface between your computer and the program. Here's my giraffe. I will make it bigger. Key, move to the platform. And now let's duplicate it. And move. Okay, so
How do you know how big it's going to be?
how do I know how big it's going to be? That's a good question. There's a tool in here where I get to choose exactly how big it's going to be. I can adjust its scale. So I'm going to make this just an inch high so it doesn't take too long to print out. And then duplicate it. And don't want it that big. It's getting out of hand. Okay. All right, so there are two happy little flying giraffes. And I just have to turn on the supports so it can print all that overhang. And I'm going to print what's called a raft, which is a little base support. That's the first thing it'll print. You'll see that. And I hit print. And now it's preparing it.
Which parts need the supports? The wings?
So it would be, yes. So this will take 15 minutes. It'll print. I'll show you the supports. It's going to show me a live preview here. It'll be the wings and the tip of the head. As you can see on the computer here, maybe, there's just a few supports, really. Its tail and the head, because it starts from the bottom up.
And why does it need the supports?
It needs if it didn't have the supports, then it would be trying to print in midair. And we're not there yet with printing in midair, but I'm sure we're getting there.
So it's not because the material is too soft and it would...
That is correct. It's not because the material is too soft. So now what the printer is doing is it's heating up its temperature to 230 degrees Celsius, and then it'll print out a little test strip and then start the print. And like I said, it'll take 15 minutes. So I can answer. Thank you, Roy. You'll see the printer will change from blue to red as it heats up its temperature.
Oh, okay.
So yes, question over there.
Hold on. We're getting
All right, I heard you say that technology isn't advanced enough to print in the air, but yet it's advanced enough to make a 3D pen.
Well, a 3D printer is really a glorified glue stick gun that has motors that can control whether it goes forwards or backwards and up and down. So, yes, I don't think, I'm a little surprised that 3D printers have been around for a good while. It's just they've been very large and very expensive and used by manufacturing companies. It's only relatively recently that companies like MakerBot were able to come up with their own software, which may be open source. I could be wrong about that. But everyone was able to at least replicate it very quickly. the software that allows all of these things to move when they should move. The parts themselves are not that radical. People build these from scratch. You can buy kits where you build them from scratch, but you can also source the parts on your own and build it from scratch.
Jeff.
Another question. Yes, sir.
What about multiple colors in an object? Can you load more than one color spool and tell it switch from red to green or blue to white and so forth as the object's printing?
That's a good question. With a printer like this one, you certainly can. You can pause it, and then you can change out the spool midway to another color. There are lots of printers now that have dual heads, that have 2 extruders or even 4 extruders, so that you have multiple colors at once, and so it can print them out at the same time, or at least one after the other very quickly. There's also a device, at least one device that I know of that I'd like to get eventually, that'll work with any 3D printer that sits next to it. And what you can do is you can feed several different colors into it, and then it'll basically make a filament out of that and feed that to your printer. So you can even use an older model printer if you have one and print out different colors and even different colors and different gradations. That's a good question.
So how are these being marketed to the public? Is it just for fun? Do they market them for specific reasons? Is there a reason I would buy one of those printers over another?
I think that some of them are being marketed specifically for different demographic groups like children. Like the one that I was suggesting earlier, that very small one, is specifically geared towards children. And there are others like it that are made to be very simple and very inexpensive for children. And there are some big name companies that are getting into it as well, like Dremel, and I think even some toy companies. But for the most part, they don't do too much advertising except for online, because the people that are interested in this stuff and other maker technologies like Raspberry Pis and Arduinos and scanners and all of that, all of which I have in my lab, kind of know where to look to find stuff. Yes, a question over there.
Question. Currently, I did see that you had the photo of a prosthetic that was made. So in the medical science field, is there anything made on a smaller micrometer scale for surgery?
Yes, that's a good question. In the medical field, I'm not quite sure how small they can get. I'm sure it's very, very small, especially compared to a machine like this. But yes, they are starting to use 3D printing to print parts for prosthetics and lattices for skin grafts, and even I think that China's been pioneering some of this, even some metals that are used, even some 3D printed metal parts to use to heal people's injuries if you have like a broken leg or something like that. Yes, and I believe that the very next talk about, the very next Science Cafe is about 3D printing in the medical field.
That'll be October 29th.
There you go.
How much does a spool of filament cost, and how
That's a
how
good-
long does it last?
That's a good question. A spool of filament typically costs around $40. There are some for $20. They're very easy to find and price out on Amazon, for example. I typically use there's a company called Hatchbox and a company called MakerBot that makes this printer that release filament. There are lots of companies now that make them. And how long do they last? It entirely depends upon how much you're printing and how much plastic you're using. I mean, if you just have it at home for your own purposes, it's probably going to last quite a while. But if you're trying to crank out things every day, then, if you have all-day prints, then it might not last too long. Oh, what was that? Yes. The question is, how much waste is there? There could be zero waste. It depends upon how you make your models. If you make your models so that they don't require any supports, then there's zero waste. That's what I've been doing. I've been learning how to create 3D models of larger things in pieces in such a way that there is zero waste. It requires zero supports, and then I'll just hot glue gun them together later, because I'd rather do that than have to continually order more filament. Good question. Yes.
Do you have any experience with printers or services that do ceramics or porcelain?
Ceramic printing? No, I do not, but it is exciting.
So I have one question.
Yes.
What about 3D printing in educational environments for low-funded schools?
For low-funded schools, 3D printing. Since there are relatively cheap 3D printers that you can get now, around $200, and there are many grants that you can get now that'll give you 3D printers, especially in this area, the Triangle area of North Carolina, there are many schools now that have 3D printers. And so what's the benefit of it in education? Well, printing aside, 3D modeling as a skill is a fantastic skill to have, because it doesn't matter whether you're gaming, it doesn't matter whether you're in any field in science, 3D modeling is used. And even if you don't have a 3D printer, you can start learning how to do 3D modeling today at home with your own computer using that free software that I referenced, like Blender. So for education, especially in low-income communities, it's great because you can, even if you don't have the printer, like I said, the hard part is the modeling. It's not the printing. The printer's doing that on its own. You can learn that on your own. And if you don't have a computer, if schools don't have enough computers or you can't afford a new computer, you can get something like a Raspberry Pi, a mini computer, which is a $35 Linux computer, which you can look up as well, and you can check them out in my lab too. Those are fantastic. And they'll run 3D modeling programs too. Yes, yes, sir.
Is there a maintenance issue in terms of having to clean the heated nozzle in the head, or is that a problem? Does it gum up after a while?
It does a bit. As you can see, there are many moving parts, so it's like a car. It has like a little odometer that tracks the hours, and over time, it does need maintenance, and it does need parts that have to be replaced. Most of the maintenance just requires greasing things up to make sure it moves smoothly, but the nozzle itself wears out over time. However, the nozzle is just a few dollars. It's just a little brass nozzle. And so I've had to replace a few parts. The most expensive part has been $30. So it's not bad. Yes, yes, sir.
I'm thinking of it as a way to produce art. We call it printing. That's an art form with various types. But it's also a lot like sculpture, like clay sculpture, not like carving into wood or stone, but rather accretion, like clay sculpture would be. Do you know whether there are artists doing printing or sculpture with this technology?
There absolutely is. That's a great question. And it's a new type of art form, and it's phenomenal. If you look it up online, you'll find many, many examples of it. Because some of them will create something from scratch. A lot of times they'll make something that's wearable, like an exotic headpiece or a dress or something like that. But there are also artists that are taking data from the real world, like maybe a recording of the sound of your unborn child's heartbeat, taking that data and creating a 3D printed image of what that waveform would look like. And I mentioned jewelry before as well. There are people, you can go on to Etsy right now. I have a volunteer who's done this and has bought 3D printed jewelry off of there, metal jewelry. But yes, it's something that artists are using more and more. There's also, it's becoming a bit popular in the artistic community. There are 3D printers that are entirely built into pens. that are becoming popular. So if you can imagine this shrunk down to the size of a pen, now it doesn't control what's printed, it simply extrudes plastic, and then it's up to you to create the shape. And so they're able to make these basically kind of draw almost in midair, but starting from the bottom up, they can create an entire sculpture from nothing using that filament. That's becoming popular as well. You can get that. It's like a toy you can get on Amazon. They're not very expensive. That bypasses the modeling. Yes, you're printing from hand. It's as if I ripped this off and just started moving my hand around while it's extruding. Yes.
I've heard that you can print parts for the 3D printer itself.
That's correct. You can print parts for the 3D printer itself. There are parts of this machine are made out of plastic, so you can create a replica of it or download a replica of the plastic parts and 3D print those. Other people have 3D printed modifications that they've made to these machines, so that you can alter it, make it more efficient on your own. That's a good point.
I was wondering if the feedstock could be some kind of a wax to where you could actually make a wax model that you could use for lost wax investment casting.
It can be virtually anything. You're able to adjust the temperature of the nozzle. So the temperature of the nozzle is adjustable, and you can also buy nozzles with different size holes. And technically, you could drill out that hole yourself if you wanted to. And that leads me to remember a really interesting point, and that is that, as you can imagine, 3D printers is going to be a big part of everyone's future, whether you have one in your house or not. But the fact is that the fact that you can use almost any material means that people are making printers for all sorts of really great exploration and humanitarian issues as well. Because you can make large printers that print using the resources that you have in the community, such as the mud that you have. So maybe there's a disaster somewhere where it's difficult to get all the lumber and concrete and everything that you need. Well, if you just have some kind of binding agent, some kind of glue, and you have mud, then you can use a printer to print out dome houses. People have been able to print houses using 3D printers. This can be scaled up to any size. So what they can do is they can print out like a little mud house or a concrete house, and then if the printer itself is on tracks, it can just move over and print another one. And it may also come in very much in handy on other planets, like on the moon or on Mars, because one of the big issues there, when you escape the Earth's magnetosphere, is radiation. And one really great way to absorb radiation is using rock and mud. So if you have a machine there that can take the rock and the mud and make a dome structure that you can then live in, then that'll help a lot to eliminate the effects of the radiation.
Matt, have you considered the environmental implications of giraffes with wings?
Of giraffes? No, I have not. So I can't guarantee what's going to happen here. It could be anything. So the giraffes have printed, and let's see how they look here. Hopefully I didn't break any of them. That's good. Okay, so they have a few little supports. They need a little bit of cleanup. So when you're printing things in really fine detail, there ends up being little tiny pieces that you might have to take off using pliers, and I'll play with them a bit more later.
What's the biggest and most complicated thing you've printed?
What's the biggest and most complicated thing? Something that I almost brought tonight, but you could see some other time. Up in my lab, I've designed a pair of goggles. I don't know if everyone or if anyone has heard of a device called the Oculus Rift. It's a virtual reality device. So it's a headset that you wear on your face, and when you turn it on and run a special program, it'll look like you're somewhere else, maybe inside of a game or maybe standing on the moon. And then you can look up and down and all around 360 degrees. It's virtual reality, and you can see everything around you. It just it tracks your head. So I've made one of those using a 3D printer. I used Blender to create the models, and then I bought all the parts using Arduinos and screens and all sorts of electronics to make this device that'll recreate virtual reality when you wear it on your face.
Matthew, I'm passing around a duck's foot. Why would you print a duck's foot?
Okay, that's a good question. Yes. So I have several different prints here that you all can check out. One of them is a duck's foot. That duck foot was made by someone else that printed out a flexible version of it for a duck that had lost his foot, and it became a prosthetic for that duck.
How would you clean this off without breaking it? How does the usual way of doing that?
You would use a pair of pliers. Is usually the easiest way. So that's what I'll do. There are some little like spidery web like plastic bits on it. Since I made it so small, there's a good bit of that stuff. So it just comes off very easily.
What's the biggest thing you can make it with this printer, do you think?
With this printer here, it can build something the size of this platform, which I believe is like 8 or 9 inches. And then pretty much up to here. I don't remember how high that is. It's like around 10 inches. So a model like this can print something fairly large. Now you can create a model in your program any size you want and then slice it up into pieces, print out the individual pieces, and then glue them together. And I've done that as well.
Do you have 3D printed stuff in your house?
I do not have 3D printed stuff in my house aside from possibly the odd little shell or dinosaur that maybe my daughter took home with her by accident.
Matthew, this seems to have a lot of potential industrially and commercially, in medicine and science and so forth. Are lots of countries competing? Is there a gap emerging in among nations in manufacturing and so forth?
That's a good question. Well, 3D printing, there are 2 different 3D printing worlds. One is the manufacturing world, and that's the one I know the least amount because those machines are very, very large and very expensive. Machines that are made at the consumer level, I'm willing to bet anything they're more available in this country than anywhere else because the maker culture, this culture of people that make things using electronics and computer programming, 3D printing, is relatively new and is not found in many other countries. And the reason it's come about at all is because all the gadgets that you have in your pocket, your phones, your computers, are all mass-produced, which means that all those little components inside are mass-produced, which means that you can buy those individual components for pennies a piece or $1 a piece. And people have done that. And then they've done amazing things like make printers like this and sell them.
So we've seen a huge realm of possibilities for 3D printing tonight. And thank you, Matthew. Thank you very much.
Everyone.
As usual, Matthew will be here for a short while, and I'm sure if you have any further questions, you're welcome to come up. Thank you very much for coming out again, and please come again next week.
Thank you. And I have a handout up here that you all can take or take a photograph of that has all the links and all the names I talked about in the talk. And then you can check out these 3D modeled parts here, and you can touch them as well. So please come up.